Okay, so here's my most recent project. Now I just finished breadboarding it, and I'm soon going to transfer it over to the main robot platform right there. And what it is, it's an autonomous Bristlebot. Now what a Bristlebot is, it's a toothbrush with a vibrating motor, and when the motor vibrates, it creates forces against the bristles and it pushes it in a certain direction. Now if you go on YouTube or evilmadscientist.com, you can find the Bristlebot, and if you watch any of the videos of it, it's completely random the direction it goes. I mean, it goes in a single direction, but has no control. It'll run into walls, flip itself over, zoom around the room, and yeah, so I want to take that up to the next step. And what I'm going to do is I'm going to try to take control of the bristles and make an autonomous robot out of it. So what I've done is I've actually bought 4 toothbrushes right over there, and I'm going to put 4 vibrating motors from pagers on each of them and mount them to each of the 4 nodes on this robot platform. And the direction at which they move, I'm going to point the front to this direction and the back to in that direction. So by independently controlling the vibrating motors on each bristle, I should be able to control the direction at which it moves. Like if I ran the front 2, it should go forward. If I run the back 2, it should go backwards. If I run this one and this one, it should turn left. And if I run this one and this one, it should turn right. And I say should because I'm not sure if it's going to work or not. It's just a plan, and hopefully when I build it within the next day or 2, I'll have it running and working. If not, I might just stick some wheels on it and build a normal autonomous robot that has been built hundreds and hundreds of times before. Boring though. That's why I want to create something new. And here's the platform. I'll show you it working. You plug it in right there. You can see the green light goes on, and what the green light is it means it's in running mode. If you look at the 2 orange LEDs right there, there's actually 4 of them, 2 in front, 2 in back. Those represent the motors running. So the 2 front ones are running, meaning it's going forward. Now if I hit this button, shuts the orange LEDs off, turns the red one on, meaning it's in stop mode. So if I hit it while it's running, it'll stop. I can adjust the potentiometer and a bunch of other sensors on it, which I will explain in 1 second. So I'll hit running again. Now what navigates this thing are 3 sensors I have. One being the infrared rangefinder, which tells distance through an analog digital conversion to the AT-Mega 8. Then I've got 2 photoresistors right here and 2 touch sensors. Now the touch sensors and the infrared rangefinder are self-explanatory, but the photoresistors, what they're going to do is actually tell the robot when it falls, it's going to fall off the edge of a table. So while this robot's navigating on the table, if it comes to an edge, it'll know to turn around. How it does this is it uses these 2 blue LEDs to reflect light off the tabletop and be read by the photoresistors, which produces a low resistance because it's bright, and when it's dark it produces a higher resistance, so that when it goes off the table, let's say it's mounted right on this node, goes off the table, the blue LED will no longer reflect off the table, and the photoresistors will not read that blue light anymore, and it will detect the voltage drop because it's less resistance, and it'll turn around and continue on its journey. Before I show you the sensors working, I want to show you some additional components which I've stuck within the circuit. So first of all, I've got a blue potentiometer right there. It's a 10K linear, and what that is used for, it's used to control the light level at which the photoresistors react to darkness. So when it's turned all the way to the left and the voltage is highest across the analog to digital converter, it'll actually react to levels of darkness that are beyond pitch black, so nothing will happen. So as you can see, if I cover up either of them, the LEDs do not change. And as I said earlier, these LEDs represent the motors moving. So if the front 2 are moving, if the front 2 are lit, the front 2 vibrating motors are actually moving. So if I turn the potentiometer a little to the right, counterclockwise, right, oops, like this, you'll see that eventually the level at which the photoresistors react is the current light level. So they're reacting. if I turn it a little back to the left, it'll be going forward. Now it is set so that when the light changes very slightly, it's on the verge so that the LEDs will react and it'll know to turn around. So if I cover up the left one, you can see that it's turning right. And if I cover up the right one, you can see that it's trying to turn left. So that's how that works. And I think that's all the additional components I've stuck within here. So I'm going to show you quickly how the infrared rangefinder works. So if I stick my hand between like 8 and 27 centimeters away, it tries to turn right. If I lift my hand up, it stops, put it back down, turns right. Zoom out a little. I don't know if you can see the little LEDs flashing when I put my hand down. That's that working. And I showed you the potentiometers working, the photoresistors working. So that's basically it. With those sensors, it should be able to navigate around a tabletop and hopefully not fall off if I have it programmed correctly. Which is why I want to show you really quickly the code in the circuit. You don't have to actually read it, I just want to show you what it looks like. That's my header file. And this was all written in C and compiled in AVR GCC. Here's my main file. And then going to my schematic, which I drew, and I did this in Eagle, gray program. And that's basically it. I'm going to build that onto this board, this vector board, hopefully today, and hopefully it works. So yeah, that's it.